Okay. So I saved slant asymptotes for the end because they're just kind of this special case. But they technically go with the very first thing that we found, horizontal asymptotes, because slant asymptotes also describe our end behavior. Okay, so in the case where there is no horizontal asymptote, because the degree of the numerator is greater than the degree of the denominator, there's a very specific case when it's exactly 1 degree greater. So x cubed over x squared, x to the fourth over x cubed, x squared over x over nothing, although technically that's just a linear function. But those are the cases where we have slant asymptotes. And in those cases, to find the slant asymptote, you divide using long division. And I mentioned yesterday that we're not going to have to worry about the remainder. Okay? We just want the quotient part for the slant asymptote. So let's go through example 4. We're going to go through the whole list. Okay. Thank you. That's quite the entrance. We're going to go through the whole list of everything here on example 4 and beginning to end. Okay, starting with horizontal asymptotes. Now, if you have a slant asymptote, you don't have a horizontal asymptote. Okay, you don't have both. It's either horizontal or slant. So, example 4, number 1, you start by saying, oh, well, that does not have a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. So no horizontal asymptote. Let's factor. We can factor out an x in the numerator, and that leaves us with x minus 1. So usually when we factor, things cancel, but in this case, nothing canceled. So that means we don't have any holes either. Okay, no horizontal asymptote, no hole. What comes next? Vertical asymptote. Where's our vertical asymptote? X equals -1. Vertical asymptote's the denominator set equal to 0. So we solve that for x. X equals -1. All right, so then the last question we ask ourselves is, do we have the scenario for slant asymptote? Is the degree of the numerator exactly 1 degree greater than the denominator? It is. So that means we proceed with long division. So we've got x plus 1, x squared minus x. It doesn't have a constant term, so we need to put a placeholder there at the end, plus 0. All right. Do y'all want me to do the work out to the side, or are y'all okay? Yes. Okay. So x squared over x is x multiplied times x plus 1. X times x is x squared. X times 1, positive x. Change the signs and add. First term cancels. That's supposed to happen. Be careful with this. A lot of people say this cancels. Negative x plus negative x. That's -1 plus -1. That's -2. It does not cancel. It's -2. All right, so then we take -2x and we divide it by x and we get -2. You can stop at this point. You do not have to finish the process because this is all we care about. Okay, x minus 2 is all we care about. I got to the end of my line. As long as everything's lined up, you can do this. If you don't line things up, then you don't really know when you're finished. But if you line it up, you're good. So we have a slant asymptote at y equals x minus 2. It is a line, so it needs to be written as y equals. Now let's just take a quick glance at how this looks. And I'm going to show you how you can check things, okay? So like yesterday, plug the original in. This one didn't simplify, so we don't need to worry about putting a simplified version in y2. But what we are going to put in y2 is our slant asymptote. We're going to put x minus 2 in our y2. And we're going to graph. So there's our rational function. You can kind of see that slanted behavior. Instead of it leveling off horizontally, it is doing it on a slant. And then you can see how the slant asymptote just fits perfectly right in there where it's supposed to go. Now, for example, say that you said negative x plus negative x was 0x. all you would have gotten for the slant asymptote is x. So let's see what that would look like if our slant asymptote was not correct. If you had just gotten x as the answer, there's the rational function. Okay, see how that doesn't fit in that groove, so to speak, in the function? You know something went wrong. You got to go back and you got to check something about your rational or about your slant asymptote. Nothing's wrong with the rational function because we just typed it in. Unless you forget your parentheses. You got to put parentheses around the top, parentheses around the bottom. Okay? So it should fit right there in between the rational function if you did the long division correctly. Okay? All right. Let's keep going. Let's do a couple more examples. X squared minus x minus 2 over x minus 1. So obviously we're using these specifically for slant asymptote purposes, so there's not going to be a horizontal asymptote. Next question is there a hole? Factors x minus 2, x plus 1. So kind of similar to what we just had. It's close, but it's not exactly. And here's a very good example of where you've got to be careful with your signs. If you get that plus and the minus flip-flopped, then you're going to say there's a hole where there's not actually a hole. All right, so this one doesn't have a hole. Okay, and then vertical asymptote. Do we have one? Yes, where is it? X equals 1. Okay, so then the last thing is slant asymptote. So we divide x minus 1 into x squared minus x minus 2. Okay, so x squared over x is x. Multiply. X times x is x squared. X times negative 1, negative x. Be careful. Okay, those cancel. This time it does. Negative x plus x, that is 0x. Okay, that is 0x, and you bring down the minus 2, but then 0x over x is 0. Okay, so you don't really want to write x plus 0, but I'm just illustrating here. So in this case, our slant asymptote is just y equals x. Now, I don't know about you, but that makes me a little nervous that that canceled, so I'm going to check it. X squared minus x minus 2 over x minus 1. Okay, this is it's a really good way to catch simple mistakes. Okay, so here's our rational function, and there's the slant asymptote. It fits perfectly right along that groove, so we're good. Okay, all right, one more. Let's make it a little bit longer. Okay, so no horizontal asymptote because the degree of the numerator is greater than the degree of the denominator, and it is exactly 1 degree greater. So really, if you wanted to go ahead while you're thinking about degrees and conditions, if you wanted to go ahead and do your long division, go ahead and do it. Figure out the slant asymptote. For whatever reason, I always just save that to the end. All right, let's check on the holes. How do we need to factor that numerator? Grouping. Okay, so we take an x squared out of the first two terms. 2x plus 5 is what we're left with. We take a negative 4 out of the second two terms. That leaves us with 2x plus 5. How do we factor that denominator? X plus 2 times x minus 2. Difference perfect squares. They like to use those. Don't overlook it. Okay, we got to continue with our grouping. 2x plus 5 times x squared minus 4. Well, fortunately, we just factored x squared minus 4. And I do want to factor it here because I'm going to need it in factored form anyways when I solve these. And I'm going to run out of room. There we go. Just made it. Okay, so this one, we finally do have one with some holes. So let's see here. Where do we have holes? We have one at negative 2 something and positive 2 something because x plus 2 and x minus 2 cancels. 2x plus 5 is our simplified function. So when we plug in negative 2, 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. When we plug in positive 2, 2 times 2 is 4. 4 plus 5 is 9. So there are our two wholes. How about vertical asymptotes? None. Our denominator's gone. After we simplify, there's no denominator, so there's no vertical asymptote. And then for our slant asymptote, let's check it out. X squared, we're missing the 0x, or we're missing the x term, so we put in 0x there in its place. 2x cubed plus 5x squared minus 8x minus 20. Okay, so 2x cubed divided by x squared is 2x. So we get 2x cubed plus 0x squared minus 8x. Change the signs and add. Cancels. We've got 5x squared plus 0x minus 20. So then we've got plus 5. That's interesting. Isn't that our simplified version of our function? It is. Okay. This is kind of a special case because it's simplified all the way down to a linear function. Then that is your slant asymptote. Okay, it's kind of weird, but that is your slant asymptote. So let's look at this. 2x cubed plus 5x squared minus 8x minus 20 over x squared minus 4. Just checking to make sure everything checks out. 2x plus 5. Okay, here's our rational function. It looks like a straight line because it's simplified all the way down to a linear function. So let's look at the table to confirm our stuff. Wholes at negative 2, see the error, see the y value in the simplified version. Okay, and positive 2, error in the original, y value in the simplified. No vertical asymptotes, so those are our only two errors. And that's it. That's it. All right, so what I need you to do